Good afternoon, sir. My name is Reshma and I am from CSCB section. My roll number is 234C1A05D1. Today I am going to present an PPT upon the topic is called hash table operations. Subject name is data structures and subject code is 23CSC201 and entering into PPT outline. Outline means which contains the important points, important topics of the names which we are going to discuss in the upcoming previous slides. So what first point is what is hash table, and second thing is what is hashing. Next, calculation of hash key operations. Operations means which contains three types. First one is insertion, deletion, and searching. Last PPT will be the about conclusion. Moving to next slide. The first point is hash table. A hash table is a data structure that is used to store keys or value, widely used in many kinds such as arrays, strings, and data-based indexing. This is called hash table. And moving to next slide. What is hashing? Hashing is an efficient method to store and retrieve elements. The process of transforming any given key or a string of characters into another value. This point is very important and it gives a clear meaning of what is hashing. So we are going to discuss one small example according to our day-to-day life. It's exactly same as index page of a book. In index page, every topic is associated with a page number. So we want to look some topic, we can directly get the page number from the index. Likewise, in hashing, every value will be associated with a key. Using this key, we can point out the element directly. So here they are compared the page number with the key. Key equals to page number according to this small example. So we can found the element which we are searching easily with the key. So moving to next slide, operations and hash table. So we are discussed in the previous slides. Operations means insertion, deletion, and searching. Insertion means adding key value pairs into hash tables. Searching means looking upon a key to find its corresponding value. And deletions means removing a key value pair from the hash table. So clearly in one word we can mention that insertion means adding, deletion means removing, searching means searching just for a element, like looking up for a element. So moving to next slide, how to calculate the hash key. In the previous slides also we have discussed hash key. So we need to know what is hash key and what its importance also. Let's take a hash table size as 7. Size equals to 7. Array size. Formula to calculate key is key equals to element modulus size. If we take modulo of number with n, the remainder will always be 0 to n. Exactly, array index also starts from 0 and ends with n equals to -1. So we can easily store the elements in array index. So here array starts from 0 to n-1. Key also same as 0 to n-1. Moving to next slide. Insertion. Whenever an element is to be inserted, compute the hash code of the key passed and locate the index using that hash code as an index in the array. Use linear probing for empty location if an element is found at the computed hash code. Here, linear probing means a method which is used in the hash table to find an element. So this is called insertion, and we have mentioned one example also here, in which we have declared the size of an array is 7 and element which we are going to found in the array is 24. So key we have given is 3. So we have discussed about the formula of the key also, element modulus size. So key equals to 3, in which I have said that index equals to key. Then array size equals to 3, array index 3. In the array index 3, we have found the element. So key equals to index, we can say that easily. Here also I have given 2 more examples of it. Size element we have mentioned and key. So we have found out the element there in the index 1, where key equals to 1, index also equals to 1. So key equals to index, it is equal in this case. So moving to next slide. Here I have provided the code of the insertion in the hash table, how it works and everything. Then moving to next slide, which is deletion, second operation. Whenever an element is to be deleted, compute the hash code of the key passed and locate the index using the hash code as an index in the array. Use linear probing to get the element ahead. If an element is not found at the computed hash code, when found, store a dummy item that to keep the performance of the hash table intact. Here we are not going to remove the element. The element is very important role here. We just mark the index as -1. It is indirectly delete the element from the array. Moving to next slide. Here I have provided a small example for the deletion. Size equals to 7. Element which we are going to found is 24. Then 24 element modulus size 24 modulus 7, which is 3. Key equals to 3, and we are not found here, so it is -1. We have discussed previous also. From using linear probing method, we can solve this case. Moving to next slide. Here is the code of the deletion. I have mentioned everything. And moving to next thing is searching. Whenever an element is to be searched, compute the hash code of key passed and locate the element using that hash code as index in the array. Use linear probing to get the element ahead. If the element is not found at the computed hash code, so linear probing plays a major thing when we are not able to find the element in the hash code. Okay, moving to the next slide. Here I have mentioned some examples for the hash table. Here we are searching for the element 8. Size equals to 7. Element we are searching is 8. And the element modulus size 8 modulus 7. Key equals to 1. Where we have found in the array index 1, 8 elements. So index array is 1 and key equals to 1. Index equals to array equals to 1. So the case is true and another case is false. Here we can observe that size 7, element 19, 19 modulus 7, 5. But we have not found that element in the index 5. So it is not true case. And here I have mentioned the code of the searching. You can observe that. Moving to last slide, conclusion that thus it is concluded that a hash table is a data structure. So it is important. Hash table is a data structure that stores a data associately. So it mainly works to store a data. The hash table includes key values with links to the related records. The essential principle behind a hash table is that we must enter a key value into the hash table location. So the key value plays a major role in the hash table. Without key value, we cannot do anything in the hash table. The location will be calculated from the key value itself. Address calculation, indexing or hashing refers to the one-to-one correlation between a key value and an index in a hash table. So here we can say that index equals to key and key plays a major role in the